welcome back. We had a long weekend, and I want to welcome you back to our study. We were learning how to factorize cubic functions, and now we are moving on with sketching of cubic functions. Just to remind you, the general appearance of any cubic function is f of x is equal to ax cubed plus bx squared plus cx plus a d, where d is the y cut, meaning that x is equal to 0. Let us not forget that. And all cubic functions have got only one y cut. And you should also observe that all cubic functions have at least one x cut and at most 3 x intercepts. Cubic functions may have stationary points, and I don't want you to get confusion here. We said stationary points includes both minimum and maximum, as well as points of inflection, because sometimes a point of inflection might be a result of solving f dash of x is equal to 0, and we have, instead of having a minimum or a maximum, we have no conclusion to say this is a maximum, this is a minimum, and it will at the end be observed that it is actually a point of inflection. Importantly, the coefficient of a of x cubed, which is a, when it is positive, the graph will have an appearance like the one I'm showing here, where it starts from the left with a maximum turning point and then a minimum turning point. But if a is less than 0, it will also appear, as I have indicated here, starts with a minimum turning point and then ends with a maximum turning point. We are all starting from the left to the right. These are the steps that we have to go through in order for us to sketch a cubic function. We determine the values of x of the stationary points by solving f dash of x is equal to 0. Second stage, determine the y values at the stationary point. By simply substituting our x values from 1, we are getting the corresponding y value. Do not substitute in f dash of x. When finding the corresponding value of x that we have at the stationary point, we substitute that value of x into the function f of x to get our corresponding y. Third step, determine the shape. As I said, our a determines the shape. We already know before we sketch it that it will appear either having a maximum followed by a minimum, or a minimum followed by a maximum. That is a result of the positivity or negativity of our coefficient of x cubed, which is our a. Part 4, determine the x and y intercepts. This we have been doing over and over again. When we are having a graph cutting the x-axis, y is always 0. When the graph is cutting the y-axis, x is always 0. So we simply substitute and then solve for x. Part 5, determine the x value at the point of inflection by solving f dash dash of x is equal to 0. Then you substitute the value into f of x to get the y value. Last stage, after solving for f of x is equal to 0, if a root is repeated, then that point is a turning point on f of x. Please get to understand this one. When we solve by actually substituting f of x is 0, we then solve for x and there is a repeated root, I am saying that repeated root is showing you that there is actually a turning point at that point. The point might be a minimum turning point or a maximum turning point. I'm going to quickly run through with you examples 1 and 2. Example 1 says, sketch the graph of f of x equal to minus x cubed plus 7x squared minus 15x plus a 9. To sketch that, we need to factorize. Okay, first of all, let us find our f dash of x. We are actually deriving that expression which results in that. We equate it to 0, and we should be able to factorize because this is quadratic. We have been factorizing quadratic functions over and over again. You end up with that, or you use your crisscross method, which I tried to show there, and you end up having your x is equal to 3 or x is 5 over 3. If you find your f3, you are getting 0. That is, if you substitute in f. Remember, we have a 3 when we were finding the stationary points. You substitute into f to find the corresponding value of y, which happens to be 0. So the stationary point is 3 and 0. The other one is 5 over 3. We substitute, we end up with minus 32 over 27. And this is the other stationary point. But however, f of x is equal to 0. We are now finding the x cut. We'll use our method that we have already been using in factorizing cubic functions. F of 1, we will get a 0, which means x minus 1 is a factor. Using the synthetic division, when we equate this to 0, we have x is equal to 1. That is the 1 here. And then we copy the coefficients of our f of x. There is a minus 1, there is a 7, there is a minus 15, there is a 9. So I said we drop this down. This times that, we have minus 1, we put it on top of the 7. We add this, we get a 6. This times this, we get a 6, we place it there. We add this, we get a minus 9. This times this, we get minus 9. This plus this, that's 0. So these are the coefficients of the quadratic part, which is the trinomial. Therefore, our f of x is equal to x plus 1 multiplied by the trinomial, which we get from the coefficients that we get from the synthetic division. So we factorize this. We'll notice that we have x plus 1 into minus x plus 3 into x minus 3, which is equal to 0. So our values are x is equal to minus 1 or 3 twice. This indicates that at x equal to 3, there is a turning point. Please, that's what I tried to emphasize there. So we are going to sketch the graph. On the y-intercept, x is 0, so y is 9. So it will cut at 9. We have seen that it will cut the x-axis at 1 and 3, and that's exactly what we are seeing. And we also observe that this is a turning point. Just from the beginning, we had the points 3, 0, and 5 over 3, and 32 over 27. These are stationary points. So you can see from the graph, this is a stationary point. This is also a stationary point. So we sketch our smooth graph. Remember, we said the coefficient of x cubed, which we said in this case, it is a negative. So notice we are starting with a minimum turning point followed by a maximum turning point. Then we are going on to example number 2. Consider the function x cubed minus 5x squared minus 8x plus a 12. And in A, they say determine and classify the stationary points. Again, as we have said before, we derive and we end up with that. We equate to 0. We then factorize because we are able always to factorize quadratic expressions. We have these factors, which means our x is equal to that or that. Then again, substituting these values into f, not into f dash of x. We are substituting into f of x. We will have f of 4 is equal to minus 36, which means there is a stationary point 4 and minus 36. And we also substitute f of minus 2 over 3 into f, and we end up with 400 over 27, which is approximately 14,8. Then this again is another stationary point. Then we are now using the second derivative. We derive again this expression. We end up with 6x minus 10. Then we are saying, how is the concavity here at this point? The concavity, according to f dash dash of the second derivative test, it is less than 0 because we have a minus 14. So f is concave down. Now we are saying it is concave down, which means there is a maximum turning point first. Then for this one, we have minus 2 over 3, and 400 is a local minimum, and is a local minimum and is concave down. Yes, that's very important. I think I had already made a mistake here. This point is the one that I'm talking about. Is a local minimum and f is concave down. Then we have f of dash dash of 4 is greater than 0, so that is a local maximum, and f is concave up. Very, very important for us again to remember. Then now we have part B is saying determine the points of inflection. When getting the points of inflection, we derive f for the second time. So we are getting f dash dash of x, which is 6x minus 10 is equal to 0. We solve, we get our x is 5 over 3. And the coordinates, we again substitute this, not in f dash dash, not in f dash, but in f of x. So we'll get minus 286 over 27. This is our point of inflection according to the question. Determine the roots of f of x is equal to 0. Again, equating to 0, we go through the experience, we find our factors. We notice that x plus 2 is a factor. Using our synthetic division, we get these coefficients. The rule is we equate this factor to 0, we get a minus 2, we write it here. And then we drop this one, this times this, we get minus 2, you add minus 7, this times this, that's 14, 14 plus that, that's 6. This times this, minus 12. We end up with a 0. These are the coefficient of the quadratic, which is the second bracket containing the trinomial. Then again, we need to factorize. We end up with x is equal to minus 2 or 1 or a 6. So as you can see here, it's cutting at minus 2, it's cutting at 1, it's cutting at 6. And this is our first turning point. It's a maximum turning point. And this is our second, it's a minimum turning point. And we write down the coordinates of the stationary point, which is a point of inflection. Part E, what is the maximum value of f of x for x from minus 3 to 10? So minus 3 is somewhere here to 10 after 6, so it's up there. So we are going to substitute our turn into the f of x. Then we end up with 4, 1, 2, because we can't, this is minimum, it's negative. This is positive, we want maximum. So this is the one we get. Then F says, use your graph to determine limit of f of x as x goes to minus infinity. Now we are using this graph. As x is going to minus infinity, what is happening to the graph? It's also going to minus infinity. That is why in f we have limit of f of x as x goes to minus infinity is also minus infinity. And here is our classwork. Exercise 11, number 9 only. And homework, exercise 11, you do number G only. Remember, this is where you are answering questions from 1 to 9. But then we are doing G only. I thank you.